Hello everyone, welcome to Blackbird. This is Venkat, and in this video, we will be talking about the recently released version of Java, Java 23. Talking about what's new in this. So basically, they have added Markdown documentation comments, support for duration until there is some another instant. Then they have removed thread local methods like suspend, resume, and stop. Even thread suspend has also been removed. They have had flexible constructor bodies, stream gatherers. Then they also have specified that now you can have implicitly declared classes and methods. There is structured concurrency, which we'll be discussing in detail, and scoped values. Well, there are other JEPs as well, which have been included as a preview feature or which have been included as an incubator updates, like the vector API, the 8 incubator, and the class file API that has been introduced in 466 JEP as a preview feature. So let us discuss one by one about all of them. Let's start with Markdown documentation comments. Here is a piece of code where we are performing an addition operation. We have a static method and a method named add with two formal parameters a and b. Let's say I have to write the documentation comment for this method. It would previously, before Java 8, before Java 23, it would have been something like this. In this, you can very well see that you can use the documentation annotations like param, return, code, etc. But here you had to use HTML in order to write the documentation. Now, with Java 23, what you can do is you can use Markdown in order to write the documentation, and it will be exactly the same. You can use backticks in order to denote that it is a code block, and you no need to write all of this HTML code here in the documentation anymore. Although, if you still want to use the annotations that are provided by the Java doc, you can still use them at your wish. Second is the support for duration until another instant. For this, in order to determine the duration between two instant objects, previously you had to use duration.between. With Java 23, we have this until method, which is a part of the instant class, which returns a duration between the two instant objects. So this is our until method checking in. Let us see how exactly we will do that in IntelliJ. So navigate to main.java. Let me remove all of this. Um, Public class main. Now let's say I have two instances. One is the current instant, say instant.now, and the other is sometime later. So what I'll say is I'll say plus thread local random provides me the current thread and next int. And then I'll specify that it is to be in seconds. Uh, I can statically import this chrono unit. Yeah, looks good. We are getting some kind of an error. That's because of the missing packet statement. No worries. Now, if we want to calculate the duration between these two instances, we are going to get the correct output. It is ahead by these many seconds. Moving on, there are some thread local methods which have been removed because they were unsafe. Now, what are these lucky nominations? It is the suspend method, the resume, and the suspend, resume, and stop methods present in the thread group class. Actually, all of these methods were marked as deprecated since Java 1.2. But what happened was they were just marked deprecated. With newer versions, if you had used these methods, they would throw unsupported operation exception. But now in 23, they are finally removed. And there is the coffin dance for all of these lucky nominations. Moving on, we have the flexible constructor bodies. Now, even constructors know gymnastics. I don't know when will I. Previously, it wasn't possible to execute additional code before calling the superclass constructor on an alternative constructor present in the same class with the use of this keyword. Now, in order to validate parameters and or to calculate some values or to do something with the formal parameters that we received within the constructor parameter list, we had to have separate methods which make sure that those operations were to be performed. But this made the program quite unreadable. And this is the reason why JEP 482 was introduced. The fact that we can initialize fields in derived classes only after calling super constructors could lead to a lot of problems. And thanks to JEP 482, now we can basically initialize the fields that we are receiving within the constructor parameters. But there are some restrictions for this. You may not invoke any non-static members and must not create any non-static inner classes instances. So you should keep this in mind if you are trying to use flexible constructor bodies. Let us see how we will do this. Let's go back to IntelliJ. Um, I'll create a new class. And within this class, let's say I'll have a constructor class here. Here I have private field, let's say color. This is the AWT color that we know about. Then we have this constructor so that we could initialize this field. Oops, it's no method, it's a field. And here we have the getter method, which will basically print the color. Okay. Now we go to flexible constructors, and in order to show this example, I'll extend the constructor. All right. Let's say here I have some other fields, width and height. Again, let's say I have a constructor for these, and this particular class specifies color, width and height. Now you can see that IntelliJ is giving me this option of having the super of invoking the super constructor first and before writing anything else. So what I'm going to do is I'm going to obviously be a developer and ignore what IntelliJ says, and I'm going to write my own way. So I'm adding some validations here. So let's say if the width is 0, then width cannot be negative. All right. And then I'll set these parameters. This dot height is height. And then I'm going to invoke the super with this color. You might see that there is an error here because I did not obey what IntelliJ was suggesting me. But don't you worry about it. We will get back to that. Now, let's say that I have a main method here just in order to run the application, and I write fc dot get color. All right. In order to run this, what I'll do is I'll open the terminal. I'll redirect to constructors package, and here I'll say that hey Java, enable the preview for source 23 for the class flexible constructors.java. If I do that, I get the correct output. Since it is a preview feature, IntelliJ warns you, and basically it will warn you until it's totally implemented in the upcoming versions of Java, about having this super, like invoking this particular super constructor, and to have it as the first statement in the child classes constructor. But we still do get the output. That's because we have enabled the preview for source 23. This is about flexible constructors in Java. Now let us move on to talk about stream gatherers. What are stream gatherers? But before knowing what are stream gatherers, you should know about Stream API that was introduced back in Java 8. So there are a limited set of intermediate operations that we get within this Stream API. This is the reason because streams were just brought out in order to implement functional programming in Java. And back then, in 2014 and 15, filter, map, flat map, map multi, distinct, sorted, peak, limit, etc., all these methods were enough to implement functional programming. But as the community of Java went ahead, operations like window and fold were also required but not available in the Stream API by default. So Java introduces the Stream Gatherers API, which provides various other intermediate operations which were required by the community. The best example we could understand is from the sliding window problem, a really famous problem in the world of DSA. So we will write a sliding window program where we will see how exactly it used to work before stream gatherers were into existence. So let me write stream example dot sliding window before. Right, seems good. I will want to have a static method, let's say max sum of sub array. What this method will do is it will find the maximum sum of a sub array of size k. So I'll initialize the variable arr.length, after which I'll say n should be less than k. If it is less than k, then I'll say that it is an invalid input. But if all the validations has been done, oh well, I need to return some value after printing this because I want to exit from the execution of this method then if it's not true. Then I'll come down here and I'll say that, I want to calculate the sum of the first window. So I'll write window sum is 0, then a for loop within which I'll iterate till the kth index and have the sum accumulated. So I have the sum of the first window of first k elements. I'll initialize the maximum sum as the first window sum. So here we are adding the new element of the window and removing the first element of the previous window. And exactly here we are uh, updating the maximum sum if the window size is greater. And we have started this loop from k continues till n because we have already calculated the first window sum from 0 to k. And then we basically return the maximum sum. Then let's have a main method. And within this main method, I'll have an array and some basic indexes. Let's say k is 4. And then let's find the sum, like sum of maximum sum of the subarray. Once we compile this, okay, flexible constructors, you don't have to be here. But basically, I should comment the whole class itself. Don't worry, you'll have the code posted on GitHub, so don't worry about that. So here we are getting the maximum sum of an subarray to be 39. Now, I would like to implement a sliding window with the help of stream gatherers. So in order to do that, I'll again have a main method here, and let's say I have a dedicated other method, let's say max sum of subarray with the same input. What I'll do is I'll have a instream of this array. Now if you don't know about instream, then you definitely need to understand functional programming in Java. Then I'll box this auto boxing that does not exist in this case, so you'll have to basically you'll have to box the primitive types to the integer reference types. Then we'll gather this using the gatherers dot window sliding and specifying the window slide to be k. Now we'll map this to int again. Let's say that each window should be mapped to int and the maximum should be found in this way. After which, if there is any error, then you should throw a illegal argument exception that the array size is small, because that is a possible thing that can happen around here. Now, if we try to compile this and run this code, we won't be able to because it is definitely a preview feature, and that is why we'll have to enable the preview and then only we can run it. So I'll have the same things done. Then I'll go to terminal again, navigate to stream example, and I'll say Java enable preview for the source version of 23, and the class is sliding window gatherers Java. If I run this, I get some kind of an error, illegal start of an expression. Let's see why. Okay. That's an issue. Basically, when you have a lambda expression, you don't need to specify through if you are using this or else through method. So let's run this, and you get the same output. So instead of writing that much amount of code for a sliding window technique, you can use stream gatherers. With the help of that, you can compile the code. Now, the next feature that we have with us is the implicitly declared classes and instance main methods. What does this mean? It's a huge term, but it has been introduced in order to simplify and refine the process of onboarding the beginners of Java so that their learning curve does not go exponential while they are learning Java. It reduces the boilerplate code in order to run small programs. So basically, the ideology behind this is not write any kind of classes and just start coding instantly. So what are implicitly declared classes? These are some special Java classes where the compiler implicitly wraps the top level code within the class so that you don't need to write a bunch of boilerplate code in order to run small applications. The best example has been in my videos of Introduction to Java. I'd attach link here in the description as well, so you can check that out. But right now, let us understand how that works. Again, I'll need to comment this entire thing before moving on. So I have this main file here. I just remove everything. And to have the best use of implicitly declared classes, I just write void main. You see no public, no class, no static modifiers, nothing. And I'll write println hello world. Now you can actually use this println method as well. Java has this done for you. But there is an issue, and that is that it is a preview API and might be removed in a future release. So that's okay. Not a big deal for us right now. Not our concern at this point. So in order to compile this, again, I'll have to redirect to the main project source, then enable the preview for source version 23, and then give the file name. And if I do that, I get hello world. People who keep saying that Java is verbose, this update has have them cut. So this update right here introduces implicitly declared classes. When the compiler sees that there is a main method with no string array formal parameter, or there is no class that is wrapping this, it implicitly declares a class, and within that class it wraps this main method and executes that. This is an instance main method. You can create another instance main methods within a class itself, but then again you will have to instantiate the class and then invoke the main method. So that's also possible now. Other than this, there are different other print statements that we can use. So I can say print hello, and when we run this, let me just copy and paste. So we get hello world and hello as usual. But there is something else that has caught a lot of beginner attention in Java, and that is the use of readln. If you have done Python, you must know that there is a method, something like this, where you specify some prompt, and this is used for accepting values from the user. In the same way, readln has a parameter prompt where I can say enter a name, and then I can print the greeting for that particular name. So now if I run this, at first get this prompt, let's say Krish Jaswal, and we are good to go with that. This new feature is a preview feature once again, so mind it, use it only if you want to test some things around. Once it comes into a LTS release, then it will be good to use. Moving on, we have structured concurrency. Now, what is structured concurrency? Concurrency, we all know it exists, but the simple coordination of concurrent tasks, which is characterized by the clear and visible start and end points of a concurrent subtask, is what we call structured concurrency. Right here, we have this unstructured code, and we are unable to understand from where subtasks have been started and where they are ending, which basically leads to a lot of confusion. And here you can also see an orphan thread. But on the contrary, we have this flowchart which denotes structured concurrency, where every subtask has a clear and visible start and end points. It is done, it is implemented in Java with the help of Structured Task Scope API. This has been brought about by JP 480 and introduces a control structure that defines the start and end of a concurrent task. It also enables error handling, clean error handling, and cancels those subtasks whose results are no longer required in any kind of an ordered manner. Let us write a program where we'll understand about structured concurrency. Again, I'll comment all of this. Let me say concurrency dot structured con example. Okay. Here we'll be simulating a call to an API, a weather API and a trading API. So what I'll say here is I'll have two methods, both static, one named fetch weather. Oops, I missed out an H. And within this, I can say that I want the main thread to sleep by a second. And then I'll return that the weather is sunny. And since thread.sleep might have a chance of getting interrupted exceptions, so we'll throw interrupted exception. Another API that we want to simulate is a stock API. So let's say we can do this for a second weather API. So this fetch weather 2, this also throws interrupted exception where we want our thread to sleep for 2 seconds and then return weather is cloudy. Alright. Now within the main method, what we'll say is we will have a try with resources, with this being a scope, and having structured task scope dot shutdown on success, which basically has a generic type of string. Then we'll have a callable of type string. We need to import the class, I suppose. But even if we don't, it's not a big deal. So I'll say task 1 is fetch weather and callable is fetch weather 2. Now we can say that the scope can fork on this task 1 and task 2. I need to import this, right? And now I'll store the result of this using scope.join, after which I'll print the result. Just one thing that we need to add here is we need to get this result in the format of a string, because join basically returns a task scope. And there are still some kind of errors, and that is because we have two exceptions to deal with. One is interrupted exception and one is execution exception. Yes, just like that. Now we wish to compile this. Definitely we go to terminal. It won't compile since this is a preview feature again. We'll go to concurrency package, and then we will say Java enable preview for the source version of 23 and executing the class for example.java. Oops, I meant it quite literally. And there we get the output that the weather is sunny. This happens because this particular method, fetch weather, sleeps for just 1 second and then it returns the output to this structured task scope, which on getting the output shuts down and returns the result to the accumulator that we have of type string, after which we print that. This is done using structured concurrency and the structured task scope API. Moving on, that's all for this video. If you liked the video, please like, subscribe, and share this channel with all of your friends. And thanks for watching.